x equals negative 3x squared plus 2 divided by 4x minus 1. And let's say we are asked to find f prime of x. How do I start? Very good. Thank you. Yes, very good.
Negative 3x plus h squared plus 2.
Very good.
Minus negative, 3x squared plus 2 over 4x minus 1.
Very good. Yes, I would have to agree. This is not a trivial problem because it has a lot of work. We have a lot of work to do. First of all, we have to square, and then we have to find the least common denominator, and then we have to distribute, and it's huge. Correct. A problem like this is not for a test or the final exam because it will take a long time. And I don't want to test one thing, that you know how to find the least common denominator and multiply only on a test, right? So very good. So now we have to continue. I have to simplify this first. So this is limit as h approaches 0. So this is negative 3x squared minus 6xh minus 3h squared plus 2 over 4x plus 4h minus 1. And minus, but since I have minus and minus, I'm going to distribute, so it's plus 3x squared minus 2 over 4x minus 1 over h. So I factor out negative 1, and I multiplied by negative 1 to simplify those negatives. Are we in agreement so far?
Yes.
Everyone? Yes? Any questions? Any questions here? If it's not clear, please don't be shy. So I factor out negative 1. I get negative 3x squared minus 2, and that negative will eliminate this, so I have plus. Is that okay? So the limit as h approaches 0, what is the least common denominator?
4x
minus 1. 4x plus 4h minus 1. I prefer putting the small one, the binomial, in other words, in front, and then the trinomial, but it doesn't matter, really. And now let's see what we need to multiply 4 terms by. Indeed. And what do we multiply these two terms by? 4x plus 4h minus 1. So I recommend this. So please watch for 1 second. Here's what I recommend. Distribute from the binomial always. 4x to these 4 terms, and then negative 1 to these 4 terms. Also from the binomial, 3x squared to these 3 terms, and then negative 2 to these 3 terms. I suggest that. Of course, you can get the correct answer doing it differently. That's fine. So 4x times negative 3x squared is negative 12x cubed. 4x times negative 6xh is negative 24x squared h. 4x times negative 3h squared is negative 12xh squared. And 4x times 2 is positive 8x. We only distributed 4x to 4 terms. Would you agree?
Yes.
Were you able to keep up? Yes? Okay. Now I distribute negative 1 to these 4 terms. So positive 3x squared, positive 6xh, positive 3h squared. Of course, as you know me already, I ran out of room, so I'm going to continue here. Negative 2. Okay, plus. I distribute 3x squared to these 3 terms first. So plus 12x cubed plus 12x squared h minus 3x squared, and then minus 8x minus 8h and plus 2. Now let's stop for a moment because thinking about this is more important than moving fast. We know that every time we determine the limit of a difference quotient, two things have to happen. What is the first thing that has to happen?
All terms
That do not have age, and hopefully other terms, but that would be a bonus. But definitely all terms without age must go away from the top. And then eventually what else will go away is the problem. What creates 0 over 0? Which is age, correct. So now let's find those terms carefully. So this has no age, so this will go away indeed. This has no age, it goes away indeed. 2 goes away. Okay, now I'm looking for more, and I'm hoping for more. Okay, you're also 3x squared with negative 3x squared. And now I'm hoping for more. Let's see. Negative 24x squared age. And there is an x squared age, so this and this will be combined like terms, but they will not go away. Then 12x h squared. I don't have any x h squared, so this has to stay. 6xh. I don't have, I'm sorry? I don't have a 6xh. It has to stay. And I don't have a 3h squared. And I don't have a negative 8h. So 1, this will be one term. 2, 3, 4, 5 terms will stay. So this is limit. SH approaches 0. I copy the denominator first, which I flipped h now. 4x minus 1. 4x plus 4h minus 1. And now I go back to the numerator and write those terms. Negative 24x squared h plus 12x squared h gives us, very good, negative 12x squared h. So these are gone. Now this has to stay as negative 12x h squared. This has to stay at 6xh. And this has to stay as positive 3h squared. And this has to stay as negative 8h. There is no other way. Okay, so now obviously all those terms have the problem in them. And what is the problem? H. So let's factor out h. And let's see what happens. 1, 2, 3, 4, 5. I have to have 5 terms in parentheses. And they are negative 12x squared, negative 12xh, positive 6x, positive 3h, and minus 8. Agreed?
Yes.
What goes away? Now I'm done with the limit operator. What is left at the top?
12x.
Negative 12x squared
Plus 6x.
plus 6x.
Minus 8.
That's it. Awesome. What about the denominator?
4.
Very good. And yes, I would factor out a negative 2 from the top, but nothing else. This is not a problem for a test. Good. Anything else? Anything else from the checklist? Anything else from anything else? Is there anything else that you would like to practice for the test on Monday? Any type of problem once? Any type of problem twice? And any type of problem 3 times? Yes, please, Paul.
I just have a quick question.
Yes, please.
When you provide the different limits and then we have to make a graph.
You mean when we are given a piecewise defined function and then you have to identify limits?
No,
Oh, you are given all sorts of pieces of information and you need to put them together. You want to look at another problem?
Yeah.
Very good. Very good. Let's see if there is one at the very end. I doubt. No, I don't see one. So let's go back. I don't see one in 2.8. Let's look at 2.7. I don't see one in 2.7. Let's go back to 2.6. Yes, in 2.6. Any preference? I think we did some of them. I don't remember which. So 5 through 10. Which one would you like to look at? I think we did 8 or 9. I don't remember.
Let's do 10.
Let's do 10. Very good.
Okay,
Page 140. So this is problem 10 on page 140. And this is limit as x approaches 3 from either side of f of x. They say it's negative infinity. They also give that limit. Is this on the checklist?
No, I think 8 was. Hold on. Yeah, because the one that's odd, it says it's odd, is the one that's on the checklist. This one's easy.
Good. Okay. We have f of 0 equals 0, and we have f is even. Perfect. Perfect pick. Let's work on this. Okay, I recommend summarize the information first with the chart. Yes. And let's start step by step. Here's the first one that I would like to put in. Done. Then I'm told that the limit of f of x as x approaches infinity is 2. I'm going to write what that means. Y equals 2, horizontal asymptote at infinity at least. Then I am told that the limit of f of x as x approaches 3 from either side, so here's my 3, from either side. I can put a point in there if I want to, I don't have to, is negative infinity. I write immediately that x equals 3 must be a VA. And the only thing that I have to come up with later on is f is even. So right now I am going to put in what I have. Here is the proposed graph. And when we say that the function is even, what does that mean? Symmetric with respect to the y-axis. Symmetric with respect to the y-axis. In other words, whatever I graph in the first quadrant, I have to graph in the second quadrant. Or whatever I graph in the third quadrant, I have to graph in the fourth quadrant. So symmetric with respect to the y-axis. Good. So 0, 0 is this point. No question about that. X equals 3.
So what would I mean? Just because.
Symmetric with respect to the origin. So what I have in the first quadrant, I will have in the third. What I have in the second, I will have in the fourth. Okay, so this is x equals 3. And I will have a horizontal asymptote. Y equals 2. Okay, ready? Okay, so as x approaches 3 from the left, the function approaches negative infinity. I may have, I'm just putting all this information in. I may have to change something if I'm not getting a even function. So right now, you shouldn't copy the graph. Just give me 1 second to come up with something, and then we'll decide. Okay, so from 0 to negative infinity, that's fine. And then on the other side, from negative infinity to 2. So I have the point, I have the vertical asymptote, I have both sides going to negative infinity, and I have the horizontal asymptote. Now, to make this function even, it has to be symmetric with respect to the y-axis. So I will have to have, for sure, a vertical asymptote where, yes, x equals negative 3. I will definitely have to continue the horizontal asymptote everywhere, as I should have from the very beginning. And it's clear that for this function to be even, in other words, I can do this and it will overlap. It has to fulfill everything I have on this side, it has to have it on the others, on the negative side. Otherwise, it will not be an even function. Very good. Any questions?
So an odd would be if you fold it kind of sideways, like.
What I have
like
here,
right-
what I have here, it will be here.
Yeah, so if you like folded it diagonally.
Yes, exactly.
Okay.
Yes. Good. Any questions? Any questions? Is there anything else that you would like to review?
So that -3 vertical asymptote would be required.
Yes, because of this. Yes. Very good. Anything else for me? Yes, please. Go ahead.
Can we just do like basic, like a problem like 1 and 2 from the chart?
Oh, so what does it say? Define the slope of the secant line, PQ, and choose the quadratic function. So I gave you the function. So let's use 2x squared minus 3x. So let's create a point, and let's create another point. Well, let's say 1 and 2. What is the y-coordinate for 1? Perfect. And what is the y-coordinate for 2? Very good, awesome. Perfect. Okay. So the question is asking us to find the average rate of change between P and Q, and find the average rate of change and the slope of the secant line, which we know they are the same, right? Okay.
YQ,
So the slope
oh yeah,
of the secant line PQ will be
2 minus or plus 1.
very good over 2 minus 1, which is 3. So this will be the average rate of change as well as the slope of the tangent line, the slope of the secant line between P and Q, correct?
Correct.
Okay, now we're asked, that's it. That's all we're
And then
asked.
the second one asks for the instantaneous velocity.
Okay, very good.
Point
So where
P.
would you like to determine the instantaneous velocity?
Point P, because that's what I asked for.
So you wanted P, very good. So if we want to find instantaneous velocity at P, I will determine, we'll create a function. Okay, I will consider this f of x plus 1 over x minus 1. And f of x will be 2x squared minus 3x plus 1 divided by x minus 1. You can simplify it or not, because it's factorable, of course. Or just put it directly in the graphing calculator. So under y equals, clear. And we have parentheses for the top, which is 2x squared minus 3x plus 1. And divide this by x minus 1. And I go to second and table, which is the number that I cannot even try to put in. 1, of course. So I want to be as close as possible to 1, and I can do it from either side. So I choose to put 0.9. Then I choose to put 1.1. Then I choose to put 0.05. It's not working. I'm not sure what to do. So please plug in as close as possible to 1. Okay? 0.5 is further. So 0.99, 0.999, 0.999999999. And just give me the answer. For some reason, it's not working. 0.09. Frozen. Everything is frozen right now. Sorry about that. So what do you get? So Sx approaches 1 from either side. what do you get as the slope of the tangent line at 1? Or at P, in other words. What do we get? Okay. So we had 2x squared minus 3x plus 1 divided by x minus 1. So I go to second and table. Okay, second and table. And I have 1.9, I have 1.99, I have 1.99999. I want 1.01, 1.001, 1.0000001. So the slope of the tangent line is 1. Yes?
I think another part of problem 1 was asking to explain if the slope of the secant line would be the same as.
The average rate of change, of course.
Yes.
Yes.
How would you explain? Like, I know that it is, but how would I explain it?
Okay, so this is P, this is Q, this is the secant line, and this is y2 minus y1 over x2 minus x1. So if you want to use the average rate, for the average rate, you will say f of x2 minus f of x1 over x2 minus x1. So this is the average rate, and this is the slope.
Oh, so it doesn't have to be like a couple sentences, it can be.
That's it. Yeah.
Okay, thanks.
Thank you. Anything else? Yes. Anything else? Anything else? Okay. So what we are going to continue doing for the next roughly half an hour is not part of this test. So chapter 3, and you cannot use this on the test. Yes. Chapter 3 deals with differentiation, rules, differentiation rules. Okay, so the first one that we are going to look is called power rule. Yes, we can determine many of those derivatives using the definition. However, we do have shortcuts. And you can say, why didn't you show us the shortcut from the beginning? It's because you would have not appreciated it. So here's the rule. Let's try just x squared for a moment. So we're given a function f of x equals x squared, and we want to find the derivative of x squared. We're not going to do all of them, just a couple. So using the definition. So this is limit as h approaches 0 from, of course, x plus h squared minus x squared divided by h. Right, this is the definition, the limit of the difference quotient for the function given, which is x squared. So far, so good? Okay. So, of course, I have to limit as h approaches 0. I have an agreement for this. What is it?
X squared plus 2x plus h squared.
Awesome. Minus x squared divided by h. Of course, it's 0 over 0. Of course, the terms as we expected without h must go away. Of course, we will factor out what at the top, which is the problem. Very good, as we've done this for a month already. And the numerator has 2x plus h. Of course, I'll simplify. I drop the limit operator. What do I get? Good. So h approaches 0. So it's 2x. So then, x squared prime is very good. So this is basically the power rule. Now, in general, what do you think will happen if I have x to any power? Exactly. And we subtract 1 from the power. So we bring the power in front and subtract 1 from the power. And this is what we call the power rule. Any questions about that before we look at an example?
So if it was negative to the negative 2 power, it'd be 1 over x.
So you're saying that 2 is negative now.
Yes.
Okay, so let's say x to negative 4. Negative 4 times x to negative 4 minus 1, which is negative 4 times x to negative 5, which will be negative 4 over x to the 5th.
Okay.
It works for any power, positive or negative. Okay, so I would like to look at a couple of examples on page 181. Yes, please.
I just want to make sure I understand your notation. So that is x squared prime equals 2x.
Yes. In other words, the derivative of this function, is 2x. Is this okay, everyone? Good. So let's look at a couple of examples. And no, you cannot use the differentiation rules on Monday, just on Monday. Okay, so let's look at number 14. 181. So y equals x to 5/3 minus x to 2/3. Of course, we are asked to find y prime. The only rule we know so far is the power rule. So what do you think we have to do? Just dictate. Very good. X2, 5/3 minus 1. 5 over 3 minus 3 over 3, indeed, 2/3. Minus 2/3, x2, 2 over 3 minus 3 over 3, negative 1/3. We can simplify this, and we will have to do it for chapter 4.
Sorry, you moved really quick. Or 5/3 minus 2. It's okay.
So I bring the power in front, and from the power I subtract 1. It's easier to say that I subtract 3 over 3 to get 2 over 3. So now here I bring down 2/3, and now from 2/3 I subtract 3 over 3, and we get negative 1/3. So far, so good? Okay, very good. So let's try and simplify this because this is important for the next chapter. It's not going to ask us in this section to simplify it any further. This is good enough. This is a derivative. Do whatever you need to do with it. But this is important for the next chapter. Okay. Is there a common factor present in both? Because this is what I tortured my pre-calc students with. Is there was a big handout on this, for this. So indeed, very good. 1/3 is a common factor. What else is a common factor? Awesome. To which power? And before you answer, remember we have to choose the smallest power. Don't say anything here. So if I have x to the 4th minus x squared, what do I factor out? Do I factor out x to the 4th or x squared? Of course, it makes no sense to anything else. So then I get this. Okay, so now I'm asking you again. From 2/3, yeah, negative 1/3. Very good. This is very important. Perfect. So what is left now in brackets? From 5/3, I removed 1/3. What is left? 5 indeed. From x to 2/3, I remove x to negative 1/3. So from the power 2/3, from the power 4, I subtracted power 2 to get power 2. So from the power 2/3, I subtract negative 1/3. What do I get? Indeed, not 1, but x to power 1. Good. And then minus?
2.
Very good. So the simplified form is really 5x minus 2 over 3, the cube root of x. Very important to be able to later on in this course come up with this. Why? Because we're going to set this equal to 0. And we're going to find max min. And critical numbers first, of course. Okay, so let's look at,
16.
okay, 16 it is. So we have 16. Yes, same page. We have h of t equals the fourth root of t minus, we cannot do this just now, but it's fine. I'm going to just show you what e to the t is. So why not? Let's, we'll stop here. We'll come back to it in a minute. So we are asking ourselves, what could this be? The derivative of e to the x. It's a very interesting function, very interesting derivative. So let's, for this one, and I promise I will not torture you with the definition moving forward, but just for this one, because it's important. So the function that we are looking at, and the answer is no for both questions. So I want to determine f prime. Can anyone give us the definition?
E to the x plus h power over h.
1/2.
Limit.
Ah!
Ah.
I'm not going to write anything before you say the limit, right? The derivative is the limit. And what do we have?
E to the x plus h power
Very good. Awesome.
minus e to the x.
Very good. Divided by. Very good. So remember, any derivative, we're not going to be able to do this for all functions. Very difficult. But for a few, yes, we can, as you've seen. Quadratic, rational, and so on and so forth. So this is the limit of e to, it's the limit of f of x plus h minus f of x over h. We know that. So we already went ahead and came up with f of x plus h, and this is f of x over h. Good. Perfect. Stay with me. Okay. Next step. What do you think I'm going to do? Yes, if you plug it in, it's 0 over 0. There is nothing you can do.
Factor out
Yes. Awesome. But what and how?
e to the x.
Correct. Because e to x plus h is e to the x multiplied by e to the h. Maybe that's not what you had in mind, but this is the correct idea. You said factor out e to the x, of course. Now, let's go back. When I multiply these two, do I get that? Yes, because I copy the base and add the exponents. Of course. So then, the two terms at the top have a common factor, e to the x. But since it does not depend on h, e to the x doesn't have h in it, I'm going to take it completely outside of the limit operator.
Oh man.
So why did you do that?
It's a constant. When it comes to h, e to the x does not depend on x. It's like a 2. So imagine that this is 2, and I take it out.
Is that just to clear it up?
Yes. And because the next step is this limit that we will have to look at in a minute. Yes, of course.
All right.
Of course. So let me just give you an example, if this confuses you. So let's say I have limit of 4 e to the x minus 4 divided by h as h approaches 0. 4 does not depend on h. It's common at the top. I can write 4 limit as h approaches 0 from e to the h minus 1 over h. In the same way, if you remember, limit of a constant times a function as x approaches a. This is one of the limit laws that I hope you listed for yourself.
Yes.
11, okay. I take the constant outside. We discussed this property, right? This law a long time ago. That's exactly what I did here. This has nothing to do with a variable. Like 4. 4 has nothing to do with a variable. It's a factor. If h approaches 0, these will not change. This will still be e to the x. So that's why I put the factor outside. And now, what is this? Let's put in the calculator. we don't have the tools to show you in a blink. We don't know that. We don't have that tool yet. So let's put in the calculator. Oh, I can't.
Oh, I got that tool. Calculator.
Okay, so let's see. Good. So let's see if this works. So don't wait for me. Just put in the graphing calculator, top and bottom. And what will you plug in?
E to the x.
No. You will plug in numbers closer and closer to 0 from either side. Of course, the limit is when h approaches 0. E to the x has nothing to do with the problem at this time. So in y equals, I have in parentheses e, this is e right here, e to the x, so we don't have h. I have to put x only because we don't have h in the calculator. Minus 1. Say it again.
No, that's what I said.
Okay, so second in table. And I'm going to approach 0 from either side. I'm going to just do it from the positive side. It doesn't matter. So I'm going to say point 1, 0.9. I'm sorry. I 1.0. Yes, sorry. 0.01. Then 0.00001. Then from the negative side, if you want, negative 0.000001. So coming back to our limit, what do you think that limit is?
1.
Good. So if this is 1, what is the derivative of e to the x? Ah, you're not going to see this again. This is the only function whose derivative is itself. It's the only function whose derivative is itself. Good. Nice. So now we can go back and copy the problem one more time because of course, I ran out of room. So h of t equals the 4th root of t minus 4e to the t. Okay, so now we have to find h prime with the differentiation rules. So, what power is this? Very good. So this is nothing else but t raised to 1/4. Good. I bring 1/4 in front, and then t, and I subtract 1 from the power. From 1/4, I subtract 4/4. Very good. Negative 3/4. Minus 4 is a constant, like e to the x a minute ago. And how much is e to t prime? E to t. And this is it. This is the derivative of this function, meaning it gives the rate of change at any point where this function is very good, which means continuous and definitely no vertical tangent, cusp, or corner. Awesome. Which one? Where?
I thought that entire thing that we're doing of e to the x equaling e to the x was the problem that we were originally looking at.
No. So here it is. So when we selected this problem, I said we have to hold on for a moment because I did not show what e to x prime is.
Got it.
So we had to create a new function. That's why I called it f. I created e to the x. We used the definition. You gave it to me.
I did. Right.
And you did a very good job.
Yeah, that was
So
awesome.
since h approaches 0, you understand that this is a constant. E to the
Yeah.
x does not depend on h. So I can put it in front. And then we calculated this lazily with a graphing calculator because we don't have a tool that I will show you in this chapter to determine that very elegantly. We couldn't do it yet. So since this approaches 1, the derivative of e to the x is e to the x. And you will not find another function like this one with such a friendly function. Its derivative is itself.
Yeah, that's so great.
So fun.
Good.
I loved it.
Any questions for me so far? Any questions? Okay, so let me see. I have 8 minutes left. On page 182, problem 48. On 182, and then we'll stop. The equation of motion of a particle is given s of t, motion of a particle, as t to the fourth minus 2t cubed plus t squared and minus t, where s is in meters and t is in seconds. Perfect. Find the velocity and acceleration as functions of t. Indeed. So in part A, we're asked to find v of t and a of t. How do I determine v of t? Very good. Indeed, the rate of change of distance with respect to time will give us the formula for v of t. Good. So what do you think? Minus? Awesome. Awesome. Very good. Do you all agree with this? As being the function that is the derivative of s, of the distance, which represents, in other words, the velocity function.
Because it's taking 1 down.
Yes, we are using the power rule. I bring down the power and I subtract 1 from the power. I bring down the power and I have to multiply it by 3 and I subtract 1 from the power. Yes, please.
The minus t times -1 because that's t squared down 1.
Yes, I then bring down 1 and I subtract 1 from the power. And t raised to 0 is 1. Yes, please.
What if there had been a constant, like +6?
What is the derivative of a constant? Exactly. A constant does not change. Yes. Yes. Very good. So now I'm asked to find the acceleration. How do I find the acceleration? Very good. Is the first derivative for v, or is the second derivative for s? So, can anyone dictate?
Yeah.
Very good. Yes? Very good. So this is part A. We determine the function that represents the velocity, and we determine another function that represents the acceleration. Any questions so far?
So where did the 12 come from?
Okay.
4 times 3.
So 3 times 4 and subtract 1 from the power. 2 times 6 and subtract 1 from the power. And 2t prime is 2. Is that okay?
Yes.
Does that mean no?
No. Yeah, no, I see that. All right.
Good.
That makes sense now.
Okay. Part B. Find the acceleration after 1 second. What am I asked to find? Indeed. How much is a of 1?
2.
Very good. Measurement unit. Very good. Awesome. Acceleration is measured in meters per second squared. Part C. It says it has a graphing calculator symbol next to it. Graph the position, velocity, and acceleration functions on the same screen. So we can do that. We can just plug them in. And okay. I still have 4 minutes. So find the points on the curve, 51. Find the points on the curve, y equals 2x cubed plus 3x squared minus 12x plus 1, where the tangent is horizontal. Horizontal tangent. And I just shut the book so I'm not tempted. Proud of me?
Very.
Yes.
Good.
Are you proud of you?
Yes, very proud of me, of myself. Okay, very good. So we are given a curve, and we're asked, find the points where this graph has a horizontal tangent. What does a horizontal tangent mean? When the is, the derivative must be 0. Good. So let's find the derivative first. Plus. Good. So then y prime equals 0. Means 6x squared plus 6x minus 12 equals 0. I always like to say clean it up first. What does that mean?
Needs to clean it up.
Good.
Would be one, right? X would be one.
Factor out 6.
I will not. I will clean it up.
Yeah.
Divide both sides by 6. 6 is not something that will change the solutions. You're right, but I will just get rid of it. And then
X plus 1 is 1.
careful.
X plus 2 is 2.
Very good. So there are two options, x equals and x equals. Very good. But we are asked to find points. We know the tangent to the graph of this function is horizontal when x is -2 and when x is 1, but we're asked to find the points. So what is the last thing I have to determine?
Why not?
Yes. So I'm not going to do that, but I'm just going to say f of -2, and it's just a number, and f of 1. And these are the points at which the function has